All right, this question is a little different because we're not going to use numbers at all. The question wants us to derive an expression. This is a pretty common thing for physics questions where they just give you a bunch of variables and ask you to plug stuff in and work with just variables. So that's what we're going to do in this question. We want to know if we give an object, a projectile, whether it's a soccer ball, a football, whatever it is, an initial velocity of v, and it is launched at a certain angle theta, how far does it go on the Earth? Which means we're assuming g is the gravitational acceleration. So those are the only things we have, and we're gonna call the x, the horizontal displacement, r for range. This is considered, they call this the range equation. Okay, and so what do we know here? Well, we're going to call this r, and that's our question mark, right? That's what we want to know. And other than that, we really just have variables. What we do know is, what we're going to say is that it returns to the same level from which it was launched. So what that means is the vertical displacement is going to be 0. So delta y is 0. So then what else do we know? We know we can solve for the initial velocity in the x and the y direction because we've done this a few times now. This is just going to be v cosine of theta, and this is just going to be v sine of theta. A is just negative g because we're putting in, it's down. We're going to make our sign convention: down is negative, up is positive. That's why my v was positive. V sine theta was positive. And then that's all we have, and that's all we need. So we're going to do the same thing that we did in the last 3 questions. We're going to solve for time, and we're going to plug that time. So we're going to solve for time, and then we're going to plug this in over here, right? It's the same number, and then solve for r, derive an expression for r. But in this case, we don't have numbers. We just have all these variables. All right, so let's get started. Where do we start? Well, we can start with the vertical. We know this is our don't know, don't care. So we're going to plug it in with using that same equation. Delta y equals v naught delta t, v naught y delta t, plus 1/2 a delta t squared. So this is 0 equals, and this is v sine theta t. I'm just going to call this t actually, just to make it easier. Minus, and this is 1/2 g t squared, right? Over here, so let's just hold on to that right now. And over here, we have r equals, so it's v delta, well, let me start like this. Let me say this is delta x equals v delta t. So I'm calling that r. My v is v cosine of theta, and then my delta t is t. So I've got that. Now, this is my ultimate equation. What I can do here is solve for t, and then plug it in over there. Solve for t here, and plug it in over there. Okay? So how do I do that? Again, I can do it like this. I can say this equals t, 0 equals t times sine theta t, v sine theta, minus 1/2 g t. So t equals 0, and then v sine theta minus 1/2 g t equals 0. So rearranging this equation, it's kind of a bear, but let's rearrange it and solve for t. T equals, it's going to be v sine theta divided by 1/2 g, which makes this 2, and we'll put the g on the denominator. So that is what t equals. And so we're going to take this expression and plug it in to there, right? And replace t with that. So doing that, I get r equals v cosine of theta times 2v sine of theta divided by g. All right, so now simplifying this, r equals 2v squared sine theta cos theta divided by g. And that is my range equation. This equation is pretty interesting. We can actually simplify this one more step. I'm not expecting you to remember this, but I know you learned this before, that 2 sine, it's an identity. I loved identities. I'm sure you do too. Sine theta cosine theta equals sine 2 theta. I'm just joking. Nobody loves identities, just me. So we can actually replace 2 sine theta cos theta with this identity. And when we do that, we end up with r equals v squared sine 2 theta divided by g. So it kind of makes our equation a little prettier. So, I mean, this is a very specific equation. You have to be really careful the way you use it. It only works when delta y is equal to 0. So there's no, so it basically has to rise and fall to the same height. Rise, and fall to the same height. But you can actually do some interesting things with this equation, because what you can figure out is, if you have a certain velocity, how far can you shoot the object? And then the other interesting thing you can do with this is to say, what angle would you, if you have like a gun that has the capability of, like a Nerf gun that has the capability of shooting out a Nerf bullet at a certain velocity, what angle should you aim it in order for it to reach the maximum distance? And if you think about it, so this is the question now. I want to know, what's the maximum, what angle, what theta gives the maximum range, right? That's my question. And if you think about it, this expression is a maximum when sine 2 theta is a maximum. So it happens when sine 2 theta is at a maximum. When is sine 2 theta at a maximum? Well, the maximum value the sine of anything can be is 1, right? So when sine 2 theta equals 1, so that means, so when what angle is sine is equal to 1? It's 90 degrees, right? So so that means 2 theta is going to, so sine 2 theta, so that means 2 theta equals 90 degrees. That happens. That's when it happens. So therefore, theta is going to equal 45 degrees. So what I'm saying, and what we've just learned here, is that the angle theta, when theta is 45 degrees, you get maximum range. So if a question says, you know, what's the farthest it can go, you always set the angle to 45 degrees. The other interesting thing about this equation is, because it's 2 theta, there's always 2 answers. Everything other than the maximum range actually has 2 answers. So for example, if you are shooting a ball, here's a ball, right? So then the angle 45 is kind of like this. I'm not going to be able to draw this very well. And that's going to be the maximum, right? This, if we shoot it at an angle of 45 degrees, it's going to reach the maximum range. And this angle is 45. If you do any other angle, so for example, let's say you do 30 degrees, 30 degrees will go a little bit less far. But if you do the complement, 60 degrees, it's actually going to go a little higher, but land in exactly the same spot. So every other angle besides 45 will have a complement. If you think about it in terms of the angles, it'll have a complement where 90 minus that angle is going to equal this. It's going to give you the same range. Whether the only one that's unique is 45 degrees. Okay.